We are looking at letter C, and the chapter we are discussing is chapter number 12, that is file input output. So we'll talk about how we are going to deal with the files now. Just displaying the data, we have seen how to display the data, how it is important to display the data, and we have used the printf and scanf. We have used the console input output. Now there are certain scenarios where you would like to work on the files or the data. You need to keep them for long, that is not in a volatile memory but in your non-volatile memory also. And why you want to put it in the non-volatile memory? Because you want to work on that data later on also. So for that you can keep the data in the file, and in the operating system, most of the operating system, they keep the data in the form of file. So we'll talk about the input output operations which can be performed in this chapter. Data organization. Before we can talk about the input output, first we need to understand how the data is organized in the disk. If suppose that this is your program or this is our program, we have C library functions, and these C library functions we opt for them because there are no direct input output functions in C. Rather we have library functions. We don't have any command, I must say. We have library functions, so we'll use the library function, and these library functions in turn use the capability of operating system in order to deal with the disk. Right? I hope you got the idea. So the data is stored in the disk. It is in actually the binary form. So how this binary form is stored in the disk? It depends on the operating system. But for C programmer, for us, it doesn't matter. Why? Because we are using the library functions and we are using the capabilities of operating system to perform the input output. So it is the compiler vendor. It can be any compiler from any vendor. Now it is the responsibility of this compiler to correctly implement these library functions and also take the help of operating system. File operations. When we are dealing with file or file input output, we have certain operations that can be applied on files. These are creating a new file, opening an existing file, reading from a file, writing from a file, and seeking means moving to certain specific location in between the file, and also the final one, that is the closing of a file. We'll have a program how to read from a file and display its content on the screen. So first we'll list that program and then see how and what we do while dealing with a program or how we deal with a file. So we have a program called display contents of a file on the screen, and this is stdio.h. This is very important because what we are using here, they are defined in stdio.h. We have certain variable, character variable. This is fopen. This is fopen means file open. So we use this fopen. This is the name of the file we want to open, and this is the mode in which you want to open. Now when this is being done, it returns some pointer to fp. So this is fp is a pointer. What is happening here? We have an indefinite loop. We are getting a character from this fp. Fp is now a pointer which is actually pointing to the first character of this file. So now we are taking one by one all the characters. We are checking for the end of file. If this is a file, say this is end of file. If we reach end of file, we break. Otherwise, whatever we have got in ch, we print it. So this goes on for indefinite till end of file is reached, and after that we break, and then we close the file. So what all we are doing here is this: when we execute this program, we are able to display the content of pr1.c onto the screen. First of all, what is this? We'll discuss each and every aspect one by one. Opening a file. Whenever we want to open a file, we have to use certain function. we want to open a file for reading or writing. So before we can read and write, we have to open the file. For example, we have a file called pr1.c. This is just an imaginary name, and we want to open it in read mode. So we use this fopen. This R is actually a string. Please understand, fopen, I'll show you. This is fopen. Now this is the file name in double quotes, and this is the mode in double quotes. So this is the name, this is a string, but here we use R or any other thing. I'll tell you what we use. For right now we are using R. So this is a string, it is not a character. That is why we have a double quotes here. We don't use it in single quotes, otherwise it will become a character. So fopen performs what? This fopen function, file open, it does certain activities when it opens the file in read mode. First, it will search for the file on the disk. Okay, we need to open a file. For that we have to see whether this file is on the disk or not. Otherwise, this fopen will raise an error, or it will return null. Then it loads the file from the disk into the place in memory called buffer. So from the disk it will take and keep it in the memory, that is the RAM. Now fopen sets the pointer to the first character of the file, or you can say the buffer. Now why we need a buffer? Because the file can be very, very large also. So if we have a very large file, we cannot have, this is inefficient that we take all the file and bring it into the memory. So we take a chunk or say a buffer. So say this is 100 byte. So every time we take 20 byte and place it here. This is how it is done. So it becomes quite inefficient. This is what is done. Means this is your disk. Say you have a program called pr1.c. You can just take all that in a memory, or you can take a buffer in the memory. And what fp is doing is, fp is actually pointing to the first character of this file. And when we want to write the information, so if you want to write, whole file cannot be transferred totally to disk, because the RAM or memory to disk communication is taking time, because they have different speeds. So better is to take the content of the buffer and place it there. Now this fopen, we have a file. We use file fp. Before we do fopen, we have file, and this file is called what? This file is nothing but it is a structure. This file is a structure, and this you will find in stdio.h. This is standard input output.h. So it becomes very necessary, if you use this line, you use a hash include stdio.h. So now we have a structure and we have a pointer to this structure. This pointer to the structure will be pointing to the content of the file. More precisely, it is pointing to the first character or first position of the first value or character or anything on that file. How to read from a file? Now we can read from the file. We have to use fopen, file open. This is the function we use, and we can take some buffer. Means you can partly or wholly read the content of the file starting from the first character. Now this fp is pointing where? If this is a file, fp is pointing here. Now you start reading it. When you are reading it, means you are reading the character, say, or you can read also the whole line. You can read a buffer size. This all is possible. So to read the file content from memory, we have a function called fgetc, and we will use, this is in our program, this is a fp, which is actually fp returned by fopen. Fopen, inside fopen we have the file name in double quotes, comma, the mode in which we open, and when it returns to fp. Fp is the pointer. Now this pointer can be used inside fgetc, so that one by one the character can be read. Now when fgetc reads one character, it automatically advances to the next character till the time we want it to happen. And this fgetc, if we put it in a while loop, or you can say an infinite loop, while 1, that means it is going to read one by one till indefinite. That is why we have used, or we can use in between. Every time we can check the character to be end of file. End of file is nothing but it is 26 in ASCII. So it's a special character which signifies or indicate that we have reached the end of file and we are not going to read beyond that. and when we are reading it, as I just said, EOF we use, and this EOF end of file is having a ASCII character, or it is actually a macro whose number assigned is 26. So this end of file, I must say not 26, basically EOF is equivalent to the ASCII character 26, and it is defined, this macro is defined in stdio.io.h, and fgetc is file get NC. This means from file get a character. We can also use the getc with the same effect. We have already used this getc, right? So we use this fgetc with a while loop, and we read one by one character till the time we reach the end of file. But when we are opening a file, it is not always necessary, or you should say the condition may be that the file is not there. If you want to open a file in read mode, if it is not there, how you are going to open? Or you want to write, it is not there, or I'll show you what problems can arise. So fopen we use for opening a file, and in this fopen we are passing the name of the file, double quotes, and the mode in double quotes. Now when we try to open and assign it to FP, the FP should get the pointer to the first character of the file, but it may happen that the file is not there, the file doesn't exist. So what fopen will do? It will fail. How it will fail and how it will indicate that I am failing? It will pass null to the FP, right? There are certain scenarios file cannot be open, or if you want to write the file and you see that the disk is already filled, or some writing, some boundation is there on the file. So fopen will, at that time also it will fail. So it will return a null. Fopen will return a null, and null is nothing but this fopen has defined null equal to 0. So it is going to return the 0. So how to handle it? I'll show you one program that we are including stdio.h. We are having a file pointer. Now we are opening it. Fopen, this is the name of the file, this is the mode. Now when this we want to open, this fp will get some pointer or some value. This fp, if it is null, this null, if it is null, that means we are not able to open the file. For that we have to just exit. This we have to do for every file which we are opening or closing, or not closing, opening in any mode. How to close the file? When we are done with the file, means we have done the operation, we have to close it. For closing we have to do nothing, just we have to use this fclose with the fp, and fp is just the file pointer which is returned by, say, fopen. So this closing of the file is necessary because we want this. And one more thing, when we are closing it, there are certain things when we are using this, say, fputc. So the memory is being assigned. There is a buffer also. So when we close the file, what will happen is the character in the buffer would be written into the file on the disk. At the end of the file, we'll have a character with ASCII 26. This needs to be written, and the buffer would be eliminated from the memory. That is what is done when you use this fclose. So you see that if you want really to clear things, you have to fclose. This is your responsibility. Let us write a program for counting characters, tabs and spaces. So we have known the basic input output in the file. Now how to compute number of characters and spaces, tabs, new line? These all are nothing but these are simply what? Simply because they are not seen on the whenever you type in Word or say WordPad, you will not see it. That is why they are called blank spaces. So characters, apart from this character or other from this character, all these are the blank spaces. So what we will do here, we will stdio.io.h will include, we'll make a file pointer, we'll have some variables like this. These integer variables are simply for counting, that is number of L++. This is for number of tabs, this is for number of the characters and backspaces or tabs, you can say. This L, T, B, C are for all these. It depends on you what name you choose. I'll show you how we are going to compute it, for what we have used this variable. So now the main concentration of ours is opening a file, fopen. So we are opening a file called pr1.c in read mode, and after that we are using an indefinite loop. We are getting a C from this FP, that is FP is now pointing to the first character of the file, and we are using fgetC, and every time we check for end of file. If end of file is there, we break, and we see that if character is equal to end of file, and every time we read a CH, we increase NOC, that is NOC is nothing but number of characters, so NOC plus plus. But if we get a space, if we get a blank, we get NOB plus plus, so NOB is for the spaces. If we get a /n, that is we have a new line, this is for new line, NOL plus plus. If we get a tab, we increment NOT plus plus. So depending upon what comes with fgetC, all those characters are being matched respectively with the character, with the new lines, etc. And these are being computed, and means these are being incremented and computed, and finally these are being printed. So this is just a test run of any file which you give. And this gives you the simple idea how we can use a file, open a file, and simply a program, a very good and explanatory program can be derived from it. A file copy program. That means we want to have a file which is exactly similar to this file. So all the contents from this file will be transferred here. So we want fgetC, we know that fgetC reads the character one by one. Similarly, the fputC also does what? It reads a character, it puts the character in the file. It reads the character from the file, it puts the character from the file. So we'll have a program in which character by character copying is being done. This is stdio.h we have included. We have fs and ft. We have two file pointer. This is the source, this is the target. Say this is the source, this is the target. And we have taken a character variable. Now we try to open the first file, that is pr1.c, say this is the name of the file in read mode. And we have to check whether it opens or not, otherwise will come out. Now we will try to open fpr2.c, this is our second file, this is our first file, this is our second file. And now this we have opened in read mode, we have opened this in write mode. The write mode we have to check again. If this ft fails, that means if it is null, then we come out. But if everything goes fine, this is opened in read mode, this is opened in write mode, and there is no problem, then we'll go inside a while infinite loop. From fs, that is the source, we take every time one character. If this is end of file, we break, otherwise we just put this character in the target file. So one by one, see, I'll show you here, one by one copy. This one is copied here, this one is copied here, like this, all these are being copied. And once this copy is done, there are certain buffers which you have opened, you close it by fclose. So this fclose will close the file. So this is self-explanatory, I guess, how this fputC, fgetC works. Writing to a file. Now fputC is similar to putch function, because both they are outputting the character. But this putch put the character on the visual display unit. But the fputC write to the file. So which file? Which is, say, if you have fs as file pointer, fs as source, and ft as target. So this file signify means you want to put it or write it in some file, say target file. And this goes from one character to one character, copying, and while terminates it. And we can copy or file copy program, we can do it with text file. But in order to copy the file .exe and .com, because these files are not text file, but these are binary mode. Okay. First of all, we should talk about file opening mode. The file can be opened, it depends totally on your activity or application, how you open the file. So we are dealing with disk IO, we can open the file in read mode. So read mode also has various flavors. And fopen, we can have various other options like R, as we have just seen, that R does what? It searches the file. If the file is opened successfully, fopen loads the file into the memory and now sets a pointer, which is actually the fp, we are generally using it, which point to the first character in it. And if the file cannot be opened, fopen is going to return you null, null in capitals. So this is reading from a file. Then we have W. W is for writing. So it searches file. If the file exists, please understand, if the file is existing, the contents are withdrawn, or you can say they are overwritten. If file doesn't exist, a new file will be created, and If unable to open file, it will return null. A is for appending, means you already have a file, the content are written up till here, you want to add the things from here. That means if the file is opened successfully, fopen loads it to the memory and now sets the pointer to the end of the last character. So if the file is not there, a new file is created and file is not opened, then it will return the null. Then we have R+. So this will search file. If it is opened successfully, fopen is going to load it in the memory and set the pointer again to the first character. And it returns null if the file is not, we are not able to open the file. So what are the operations which are possible? Reading the existing content, writing the new content, and modifying the existing content of the file with the help of R+. Now W+. W+ does what? Because W is for writing. So if the file is existing, the content will be automatically overwritten. And if the file is not there, new file will be created. So it is going to return null if it is if you are not able to open the file. So what are the operations which are possible? We can write the new content, read them back, and you can also modify the existing content of the file. Then A+, again append plus. So this is this searches file, and if fopen successfully opens it, it loads the file in the memory and set up the pointer which points to the first character in it. If the file doesn't exist, a new file is created, and if we are not able to open, it will return the null. So what are the operations which are possible with A+? We can read the existing contents, append new contents to the end of the file, and we cannot modify existing contents. Now string or line input output in files. We have already talked about character by character feeding or character by character reading and writing. But in various situations, we would want some whole string to be taken, which in turn becomes more efficient. So reading and writing strings of character from and to the file is quite easy rather than doing it with individual characters. So we'll write a program which writes the strings to the file using the fputs, file put string, like this. So this is a program which is receiving the strings from the keyboard and it will write them to the file. So this is our stdio.h, we have a file pointer, we have a character array. Now this is our imaginary file, and this we have opened in write mode. Now if this is not, we are not able to open it, we'll say okay, there is a problem, we come out. Otherwise, if everything goes fine, we'll say enter a few lines of text. So whenever a user is entering the line, we use while strlen means string length of this getS, means first we will take the getS, means getS function will use this string, this s we will use, we'll find out the string length. When it is greater than 0, that means we want something to be written by or given by the keyboard, we don't want it to be 0. So if it is there, we will put the string into the file, and we have to specifically, after that we have to put a /n after that for fp, and then we close the fp. So this is the sample run of this program. So what is happening here is each string is terminated by hitting enter, and to terminate the execution of program, this hit enter at the beginning of the file only. So this will create a string of 0 length, as we have seen strlen we have used, which the program will recognize as exiting, means signaling the closing of the file. So we have to set a character array as we have seen to receive the string. The fputs function writes the content of the array to the disk now, and this fputs does not automatically add a new line character. /n is not automatically added. That is why we have explicitly added, just to make it easier to read the string back from the file. This we have by ourselves added. Now we have a program that reads strings from disk file. We have already written it, assume that we have written it, and this reads strings from the file, and we want to display that on this screen from a file. So we have stdio.h, we have file pointer, this is the buffer or character array. This is the file we have opened for read, and we wanted to open it. If it is not opened, we say okay, there is a problem, we come out. Otherwise, if things goes fine, we'll use fgetS. Because this is 80, we go up to 79, this is exactly equal to that number only, and this is fb. So when we are using fgetS, we are trying to find out when we reach the null. If one by one we are reading it, one by one strings are being read and they are being printed till the time we reach the end, that is the null, and we close the FP. So this is the sample run of the program. So this fgetS takes 3 arguments. Please understand, it takes 3 arguments. The first is the address of the string which is stored. The second is the maximum length, and this argument prevent the fgets to read or overflow the array. The third argument is the file pointer, and when all the lines from the file have been read, we attempt to read one more line in which we get null and we come out. I'll show you one more time. This fgetS use three parameters. S is the character, this buffer we have used. This is the size, which is this size, and FP is the file pointer. And there is something, when we are dealing with the file and we are reading and writing, so we have written a program that counts, or just assume that we wrote a program that count the total number of characters present in that file. So if we use the program to count the number of characters present in the, say, some poem.txt, this is imaginary file, and if we count it to be 101, but if you go to the directory and we see that it shows 105 characters. Why are these 4 characters deficit, or why is this 4 more? There is a discrepancy. That is what is the awkward new line. This discrepancy occurs when we attempt to write /n to the file using the fputs. What this fputs does, it takes /n and it puts /r/n instead of /n. So this is a combination. This /r is nothing but the carriage return and /n is the line feed. So if we read back now, we have done it using fputs. When we use it, we use fgetS, the reverse conversion happen. So when we write the first line of the, say, some file and a /n using 2 calls of fputs, we get this, right? /r/n is in the place of /n. So when the same line is now read, it is being read back into the array, say this buffer or say character array. If you use fgetS, the array will contain like this, not /r/n but /n/0, and the conversion of /n to /r/n and then again /r/n to /r. This is the feature of standard library function, and this is not the feature of operating system. So operating system will count /r and /n as separate characters, as 2 characters. So if we have, say, some 4 lines, you will always find in that we assume that our file has 4 lines. So we have 4 /n to /r/n conversion. So as we have 4 character more, it will count, the operating system is going to count 4 more. That is why the discrepancy is there. Record input output in file. We can read one by one character, we can read one by one string from the file and write to some other file. Now if we want not only the characters but strings and number, because we are dealing now with, or we want to deal with the dissimilar data together in a structure. So for that we use this fprintf and fscanf library function in order to read, write data from or to file. So we will write a program and we use these structures for writing record of employees. We have this program, right, which records or write records to the file using structure. We have stdio.h, so we have a file pointer. We are trying to say user that, okay, you say yes till the time you want to enter the data, otherwise you say any other thing apart from y, you come out. So we have declared a structure which is emp. We have a name, age and basic salary. We have a variable, structure variable. Now we have opened a file now, and this is in the write mode. If it doesn't open, we say okay, we come out. Now if everything goes fine, we say while another equal to y, means we will take the character from the user, and till the time he says yes, we will do, or we will run this loop again and again till the time he comes up with a character other than y. So here we say this printf, enter name, age, basic salary, and we scanf it in ename, &e.name and &e.bs. Why we have not used ampersand here? Because this is a character array by itself. Now we use fprintf. Now we use this fprintf to print or to put the values which we have got here from scanf to the fp, that is the file pointer. So in this file we want to write ename, age and e.bs. And after that we will ask user if you want to enter more. He says yes, we will go on and on, otherwise we come out. Then we close the file. So this is the sample run. User has input 3 times. So in this program, we are just reading this data into the structure variable using scanf. Now we want to dump that into the disk, and we use fprintf exactly for that. So the user can input as many as record till the time he doesn't come up with any other character other than y. So the key of this program is fprintf, which is writing the value or in the structure variable to the file. So this is similar to printf, except this file pointer is included as the first argument. As we have seen, is in fprintf, first argument is the fp. So as in printf, we cannot we can format the data in a variety of ways. As in printf, we can have a format specifier. We can have format specifier in fprintf also, fprintf. And we have used something called fflush. Fflush is what? Fflush stdin generally we use. Nowadays we don't use it, but you should know about fflush. What happens here? This is just in order to avoid one peculiarity of scanf. Whenever we are using keyboard and whenever we are applying the content to the scanf, it assigns the name a salary to appropriate variable, and it keeps the enter key unread in the keyboard buffer. This is the thing. It will keep the enter key unread in the keyboard buffer. So when it's time to supply y or no, the question, if it arises in our program, this getch will read the enter key from the buffer, thinking that the user has actually pressed the enter key. And in order to avoid this situation, we use the fflush. So this is like the flush we use. It is designed to remove or flush out anything which is remaining in the buffer. So the argument in fflush, we have used stdin. Stdin stands for standard input, which is actually the keyboard. So now let us write the program to read the employee records created by the program we have just written. Now we took the input from the user, we have placed it in the file. Now we want to read from the file. So this is the reading record from a file using a structure. So again, we have stdio.h, we have a file pointer, we have a structure here. This is a structure variable, and this file we assume the content is already written, and we have 3 content written here. The name, age, bs, like this. So we want to open this file in read mode. If it is not open, we raise an error. Otherwise, we just do one thing. fscanf, we are scanning from the file fp. What we are scanning? The name, the age, and the bs, basic salary. And till the time we reach end of file, we just read it and just print it. Simply printf we use, and we close it. So this is the sample run. So this is the first discussion on the file input output. We will be taking one more. Till then, thank you so much and take care of yourself.